Welcome to the debate. Our focus today is on, well, a pretty fascinating and genuinely controversial hypothesis. It concerns the informational architecture of life itself, specifically, the boundary between our known biology and the theoretical dark sector of physics. Now, the source of our debate today stems from proposals by an independent researcher, Alfred, who suggests there is a necessary interaction between the two.
Right?
And the central question, really, that we need to grapple with is this. Is the recognized ordinary bioelectric field of the human body actually sufficient to fully explain these documented biological pre-patterns and also the reported observations of subtle energy bodies? Or are we fundamentally required to incorporate a novel coupling mechanism involving dark matter plasma? I'm going to argue for the necessity of this dual field approach.
Okay. And I'll be coming at it from a slightly different angle. While, look, the data from researchers like Burr and Levin is, I agree, unquestionably profound, I still maintain that intellectual rigor really demands we exhaust the explanatory power of established, measurable bioelectric physics first. I think we risk generating, frankly, too much theoretical complexity if we immediately introduce this whole infrastructure of dark plasma simply to explain phenomena that are already partially or maybe even fully explained by the intense non-neutral proton near plasma inherent in cellular systems.
Well, my position really rests on the sheer magnitude of the task we seem to be asking the ordinary bioelectric field to perform. Researchers like Harold Saxton Burr decades ago, and more recently Michael Levin, they've consistently demonstrated that organized voltage gradients, what we often call electrical pre-patterns, exist even in an unfertilized egg or developing embryo. They act as a kind of electrical template or a map. These patterns would sort of outline the eventual structure of the adult organism. They're what we refer to as morphogenetic blueprints. Now, while the existence of these blueprints is, confirmed, the functional capabilities attributed to this network, they really push the limits of what simple ionic currents can sustain. For instance, the network exhibits this incredible computational power, problem-solving complex developmental disruptions by implementing alternative functional morphologies.
Alfred's hypothesis offers, I think, a compelling solution for this informational overload. It suggests the bioelectric field acts as an interface, using a new short-ranged fifth fundamental force, which could possibly be mediated by the recently theorized X17 boson, to attract a self-interacting dark matter plasma sheath from the cosmic dark plasmasphere. This sheath, which is invisible to standard instruments, would then provide the required computational ability, the memory storage, and the persistent, detailed structure that sensitives keep reporting they see.
Okay, that's an interesting proposition. But before we jump to dark matter, let's just define the known forces already at play here. The core phenomena driving these electrical pre-patterns, charge separation, proton currents, voltage gradients, these are established facts rooted in ordinary matter biology. The sodium-potassium pumps, the voltage-gated ion channels, they create powerful electrochemical gradients. And because we have this incredibly dense and highly charged, inhomogeneous distribution of protons and ions within cells, it is often described as a near plasma, closely integrated with the aqueous environment of the body. Burr's and Levin's findings demonstrate that this electrical system is a profound tool for patterning. Yes, absolutely. But it is still a documented electrical phenomenon. Now, addressing the necessity of adding a new plasma body, we have to remember the historical failure of the ordinary bioplasma body concept. That idea was physically rejected because studies like those by Quickenden and Tilbury back in the 80s showed that ordinary plasma requires temperatures, exceeding 4,000 degrees Kelvin, or incredibly strong electromagnetic fields to maintain stability, conditions simply not present in the human body. Now, while Alfred's dark plasma hypothesis does address the low temperature constraint by proposing a coupled dark particle, introducing a weak dark electric charge and a mediating particle like the X17 boson, it means piling multiple major unverified physical components on top of the complex biology we already struggle to fully understand.
But that physical distinction is precisely why the dark plasma coupling mechanism is so necessary, and I think why it elegantly handles observations that conventional physics really can't. Let's just consider the first-hand observations reported by sensitives. If the field is simply an ordinary diffuse electrical field, how do sensitives consistently report seeing detailed three-dimensional colored structures, the aura or human energy field, which they describe as a finer substance with fluid-like organized motion? Take Robert Monroe, for example. He reported seeing the bright, normally invisible electric field lines surrounding a high-voltage cage while in an altered state of perception. Alfred theorizes that these individuals are accessing what he calls dark sight, allowing them to perceive the structured dark matter plasma sheath that is attracted to and shaped by the ordinary electric field. They are seeing, essentially, a persistent, subtle body that acts as an energetic scaffold. And that explains why they consistently see more structural detail than any scientific instrument we currently employ can detect.
I see why you emphasize those observations. But I'm not quite convinced that dark sight is the only explanation for the reported data. We really have to look at the correlation experiments. Studies, particularly those performed by Valerie Hunt, offered some pretty compelling results. When aura readers reported specific colors and shapes around the subject, sophisticated electronic instruments measured specific correlating electronic waveforms and frequencies at the same locations on the skin. Now, this correlation suggests a powerful sympathetic resonance between the measurable electromagnetic field emanating from the body and the sensitive's perceptual ability.
While Hunt herself acknowledged the standard physical model was likely insufficient, the fact that the visual data aligns precisely with known electromagnetic frequencies, well, it suggests that the phenomena are strongly tied to the ordinary electromagnetic spectrum, rather than necessarily confirming a large-scale structure made of dark matter that is entirely invisible to all our conventional detectors.
Okay, even accepting that correlation, the sheer persistence and the high level of structural information reported, like Barbara Brennan's observations of the detailed energy field persisting even after a limb is amputated, that suggests something physically substantial, something that is not simply a residual electrical signal. And this brings us to a more critical point, I think, related to biological function. Where does the incredible computational and memory power of the morphogenetic field truly reside? Levin notes this incredible problem-solving ability of the bioelectric network. When development is deliberately disrupted, the system doesn't just, crash. It uses non-local coordination to implement a working alternative body plan. We are asking the bioelectric field to perform sophisticated, long-term, field-based memory storage and instantaneous problem-solving, essentially calculating new physical realities. Attributing all this robust computational power and field-based memory solely to the ordinary ion flow across cellular membranes, it feels like asking a basic calculator to run a supercomputer program. The dark matter plasma sheath is theorized specifically to augment these functionalities, storing field-based memory and providing the extra capacity required for this morphogenetic robustness.
Okay, I have to kind of pump the brakes on the exotic physics here for a second. While Levin absolutely highlights the computational complexity, his interpretation still remains firmly within the realm of cellular biology. He specifically interprets the patterning as an emergent solution to a computational problem achieved by the collection of cells that make up the embryo, with the bioelectric network serving as the instantaneous medium of communication. Now, this is complex collective behavior, yes, but it doesn't automatically mandate intersector physics. Furthermore, we can't just gloss over the required mechanism here. Your hypothesis hinges on the X17 particle mediating this interaction. The X17 boson, based on current detections, suggests a new force that acts over an extremely short range. What is it, about 10 femtometers? Roughly the scale of a nuclear interaction. The leap from a femtometer scale interaction to creating and stabilizing a large-scale dynamic dark plasma sheath capable of non-local computational power across an entire human body is, well, it's immense. It requires accepting a wholesale new form of life physics, predicated on a highly speculative long-range biological effect stemming from a very, very short-range force carrier.
But that line of reasoning overlooks the critical factor, stability.
The need for dark plasma is driven by the physical constraints of ordinary plasma. And this leads us right to the physics of dark plasma stability and confinement. As you noted, ordinary bioplasma fails because it cannot be sustained at biological temperatures due to inherent thermal instabilities. Dark matter plasma is theorized to solve this fundamental hurdle. It's thought to be stable at low temperatures for two key reasons. First, its dark electric charge is much weaker than the ordinary charge, perhaps only 1/100th to 1/1,000,000th, which dramatically reduces thermal agitation. Second, and this is critical, the charged dark particles are buffered by a high ratio of neutral dark particles, which suppresses the instabilities that would instantly tear apart an ordinary plasma body. It's thought to be stable at low temperatures for two key reasons. Furthermore, the ordinary bioelectric field's voltage curvature acts as the template for confinement. You can think of the ordinary bioelectric field as a powerful, structured magnet in a way. The proposed fifth force couples to ordinary electrons, creating an attractive force toward these structured voltage gradients. This attracts free, dark electrons from the surrounding environment, which in turn attract dark protons, leading to the localized clustering and confinement of the dark matter plasma sheath. So this sheath mirrors the bioelectric blueprint, providing the detailed structure reported by sensitives, but crucially, it is stable at body temperature.
Right? That's an interesting explanation of the proposed parameters, but let's just examine the theoretical cost here. You are describing a mechanism that relies on a complex, interwoven set of entirely unverified physical components. A specific weak dark charge, an exact ratio of neutral to charged particles, a specific coupling strength via the X17 boson, all hypothesized specifically to make the model work in a biological context. And here is, I think, the heart of the matter. Your entire confinement mechanism relies fundamentally on the strong, structured coherence of the ordinary bioelectric field. If that ordinary bioelectric field possesses such powerful, organized voltage gradients, a kind of field lens, capable of attracting, confining, and organizing a massive second dark plasma body, well, doesn't the immense complexity and organization of the ordinary electric field itself deserve our primary focus? The principle of parsimony suggests we should thoroughly investigate the complex hydrodynamics and informational capacity of the known proton near plasma before we, import an entire dark sector infrastructure based on a proposed short-range force.
Look, the dual field hypothesis, incorporating a dark matter plasma sheath coupled by a fifth force, it just offers the most comprehensive and, I think, elegant framework. It uniquely connects the complex biological observations, morphogenesis, sophisticated field-based memory, computational power, with the consistent, if anecdotal, reports from sensitives about a subtle energy body. It suggests that the ordinary bioelectric field is not the final answer, but rather the necessary interface linking the visible body to a dark matter plasma body, thereby augmenting biological functionality beyond the constraints of standard cellular physics alone.
Well, while I readily acknowledge the challenges involved in fully explaining field-based memory, computational problem solving, and yes, the fascinating reports from sensitives, the core foundation of the observed pre-pattern still remains the measurable bioelectric field documented by Byrne-Levin. The hypothesis of dark matter plasma necessitates accepting just too many unverified physical components, requiring a complex new dark sector stability, a weak charge, and relying on the X17-mediated coupling to scale across biological distances. It risks, I think, prematurely attributing extraordinary, but potentially solvable complexity in ordinary biology to exotic physics.
Ultimately, though, both positions agree on the profound implications of Burr's and Levin's findings regarding persistent, organized bioelectric pre-patterns acting as structural blueprints for life.
Absolutely. We really stand at a critical juncture where the complexity of the bioelectric field itself demands much better understanding. Further research into the physical mechanisms governing the field's computational and memory capabilities is essential to definitively resolve whether biology has indeed found a way to utilize the dark sector for informational augmentation or or if the key lies entirely within the sophisticated hydrodynamic organization of charge within our visible matter bodies.